Okay, here we go with example 3 from the notes on April 15th. Again, step 1 says to factor all numerators and denominators if necessary. There's nothing to factor here or here, but there absolutely is something to factor here. So I'm going to rewrite the left-hand side of the equation. And on the right-hand side of the equation, I'm going to go ahead and I'm going to factor that quadratic in the numerator. Of course, the x squared is factors as x times x. What two numbers multiply together to give you 12 that combine together to give you 8? They are 6 and 2. When the last term is positive, that forces these signs to be the same, but because the middle term is negative, that means they both have to be negative. Now, I've seen in your work the last couple of weeks when you've had to factor, many of you are still using that area model, you know, the little 4 boxes, even to do simple quadratics like this. And if that's working for you, please continue to do so in your work, out in the margins, etc. Okay? But anyway, here we go. It is now factored. So step 1 is accomplished. That means we can go ahead and move on to step 2, which is to establish the domain restrictions. What is it that x cannot equal? Okay, x cannot equal 6 and x cannot equal 2, x cannot equal 6, x cannot equal 2. See how this quadratic ended up factoring as the denominators that we already had over here on the left-hand side. So x cannot equal 6, nor can it equal 2. Okay, now I'm going to go ahead and rewrite my equation in order to get myself set up to multiply by my least common denominator, the LCD. Okay, and my least common denominator is x minus 6 times x minus 2. All right, so I'm going to go ahead and show that. And if you've already watched example 2, example 1, I was really thorough in that video. Example 2 went a little bit faster. And example 3 is going to go a little bit faster still now that we've already factored. Kind of ran out of room here, but you guys are used to that with me. Oh, there's that shade. See, I told you there'd be some shade thrown, and it was thrown at me. That's fine. I can take it. Okay. Now, instead of showing an additional step where I write all of this times a 1, which no big deal, whatever, and then cancel out the x minus 6, I'm going to go ahead and look and see, okay, the x minus 6 cancels out. So I've got a 1 times an x minus 2. I'll go ahead and write that. Normally, I would not write this 1, but I just want everybody to see where that's coming from, okay? I don't want them to think, oh, magically an x minus 2 appeared. Does everybody see the x minus 6 cancels out? Okay, I forgot I'm not going to get any feedback. There's some more shade thrown at Miss Norris. Nice. Okay, second term, I've got plus. There's a numerator of x. And now if I multiply this LCD times this term, I see that the x minus 2 is going to cancel out on the top and the bottom. So that's going to leave me multiplying by the x minus 6. I'm going to go ahead and write that. Okay, and over here on the right-hand side, we're going to get really lucky because over here on the right-hand side, the x minus 6 on the top and bottom cancels out. The x minus 2 on the top and bottom cancels out, and that just leaves us with 4. So this thing is cleaning up really nicely. Okay, now I'm going to go ahead and distribute. Well, obviously, 1 times anything is just that thing, so that leaves me with an x minus 2 right here. Now I need to distribute that x. So I've got x times x, which is x squared, x times a negative 6, which is a negative 6x. I'm going to go ahead and combine like terms on the same side of the equation, which means, and start to put it into standard form since I've got a quadratic here. So I've got an x squared, combine a positive x with a negative 6x, that gives me a negative 5x. Bring down that minus 2, that's equal to 4. Let me adjust my phone here. Sorry, you may not have been able to see that last step. Okay, the thing that's holding the phone means I also can't even see everything on the phone. So anyway, just working through it. All right, so I'm going to subtract the 4 from the negative 2 in order to get everything on the same side. So I've got x squared minus 5x minus 6 equals 0. So now I've got my quadratic in standard form. I'm ready to go ahead and factor it and solve for x. Okay, so of course, x squared is x times x. Now, be careful here. I've warned you guys before. The 5 and the 6 can give you some tricky stuff, okay? I'm asking myself, what two numbers multiply together to give me a -6, but combine together to give me a -5. Yes, a 3 and a 2 would give me a 6. But remember, one of them has to be negative because of this negative. And a -3 and a +2 will never give you -5. And a +3 and a -2 will never give you a -5. So the two numbers that multiply together to give you a -6, but combine together to give you a -5 are a -6 and a +1. Okay? Now take each one of these and set it equal to 0. That gives us x is equal to 6, and this one gives us that x is equal to -1. Okay? Now, that's step 4. We solve for the variable. Okay? Step 5 says to check your solutions. Normally it says check your solutions in the original equation. But do we even need to take the time or effort to check x equals 6? No, we do not. Because in the very beginning, we established that x cannot equal 6 because that would make the denominator equal 0. Okay? So x cannot equal 6. I'm just going to mark it out and state that this is an extraneous solution. You can write out the whole word if you want, or both words rather, extraneous solution, or you can just write extra sol because that's what we all got. Okay? But now I do have to check this one because that was not part of my domain restriction, so I'm going to do that right here. I'm going to check x equals -1 in my original equation. So here we go. I've got 1. I have a feeling I'm going to run out of room here. For sure going to happen. Okay? So here we go. I think you can see everything now. Maybe. There we go. So I'm going to check x equals -1. So I have got 1 over a -1 minus 6, excuse me, plus a -1 over a -1 minus 2. I'm asking myself, is that equal to a 4 over a -1 being squared, still going to run out of room, minus 8 times a -1, lordy, plus 12, okay? That's ridiculous, but whatever. Okay, -1 minus 6 is a -7, so I've got 1 over -7, okay? Plus a -1, -1 minus 2 is a -3. Is that equal to a 4 over -1 squared is a +1, a -8 times a -1 is a +8, and then plus 12, okay? All right, so 1 over -7, that's just a -1/7, plus a negative divided by a negative is a positive, so that's 1/3. And then I've got a 4 over 1 plus 8, which is 9, 9 plus 12, which is 21. Okay, now you can go ahead and write these fractions right here as having denominators of 21, because keep in mind, in order to add fractions together, you have to have common denominators. So you can go ahead and do that, or you can employ what we've been doing through all of these rational equations. You can go ahead and multiply both sides of this thing times the lowest common denominator, which is 21. So basically you're doing what you did in step 3 of your solving, and you're doing that in the checking, okay? So as you can see, 7 divides into 21 3 times, and 3 times -1 is a -3, plus 3 divides into the 21 on top that you're multiplying by. Remember, it's 21 times 1, right, which is just 21. 3 divides into 21 7 times, and 21 divides into 21 1 time, and 1 times 4 is just 4. See how that eliminated our variables? Okay, and now I've got a -3 plus 7, which is 4. So we get a true statement here, which means that x equals -1 is a good solution, and we go ahead and box it. And that's it.